Hello everyone, this is Srividya, Assistant Professor, Department of CSIT. Today we will see the recursion in C. So this is the overview of the session. We will see what is the recursion, syntax of recursion and recursion example. So in C programming language, when a function calls itself made from the main function to other functions or from the same function itself, and a recursive function is defined as follows. See, when a function calls itself directly or indirectly, in simple way you can say, that is called a recursion. So the recursive function should be used very carefully because when a function called by itself, it enters into the infinite loop. And when the function enters into the infinite loop, the function execution never gets completed. We should define the condition to exit from the function call so that the recursive function gets terminated. So what does it exactly? Suppose if I want to calculate factorial of 5 or 5 factorial. Suppose fact of 1. So what is fact of 1? Factorial of 1, it is 1. Fact of 2, it is 2 into 1. Factorial of 2 is 2 into 1. So, in simple, how you can write? Can we write like this? 2 into fact of 1. Yes, you can write. Fact of 1 is 1. And fact of 2, it is 2 into 1. 2 factorial 2 into 1. So, you can write it like this. 2 into fact of 1. And what is fact of 3? 3 into 2 into 1. So, if you elaborate this one or if you generalize this one, 3 into fact of 2 you can write. And fact of 4, it is 4 into 3 into 2 into 1. 3 into 2 into 1, we have taken it as fact of 3. So, you can write like this. 4 into fact of 3. See, 4 into fact of 3. Fact of 3 is what? 3 into 2 into 1. And fact of 5 will be, if I want to calculate for 5 factorial, it is 5 into 4 into 3 into 2 into 1. Or else, you can write fact of 4. Suppose 5 factorial. 5 into 4 factorial you can write. Fusion, again divide this one into, see in recursion you will take a problem that is n. N is divided into smaller sub problems. You will divide the problem into smaller sub problems. So 4 factorial you can written as 4 into 3 factorial, 3 factorial, 3 into 2 factorial, 2 into 1 factorial, 2 into 1 factorial. Again, if I split this one, 1 into 0 factorial. Even now, still I want to split. 0 into minus 1 factorial. 0 into minus 1 factorial. Again, minus 1 into minus 2 factorial. Minus 2 into minus 3 factorial. See, the process is going on. We have not given any termination condition to stop. So, what in generally you will do to calculate the factorial of a number, any number, factorial of any number, you will take a loop and put the condition will be like this. While I less than or equal to n, fact equals to fact into I and I plus plus. So, this is what you will write by using this program, factorial program in while loop. While I less than or equals to n, suppose I want to calculate for 5 factorial, I less than or equal to n. N is 5 here. Okay. So, fact is initialized to initially 1. 1 into 1, 1. Next I plus plus, I becomes 2, 2 less than or equal to 5. So, in this case, the number of iterations here, I want to repeat here till I reaches to 5. After that, the loop will stop repeating. So, you will get the answer as in this case, by using the loops, you will get the answer 5 factor as 120. But in this case, in recursion, so how you will do? If you are dividing the larger problem into smaller sub problems. See, 5 factorial was divided like this. 5 into 4 factorial you can write. 4 factorial is 4 into 3 factorial. In this example, we have not given any termination condition so that it is going in an infinite loop. That is what it is said here. When a function called by itself, it enters into an infinite loop. And when a function enters into an infinite loop, the function execution never gets completed. So it will start again, next step, minus 2 into minus 3 factorial. It will move on continuously like that. We should define the condition to exit from the function call. So whenever you are writing any recursive call or you are using recursions, so first thing you need to identify the base condition. First step is identify the base condition. So where your recursion should stop, that is your base condition. Suppose here in the last case, I want to stop when at I reaches to 1. Stop, no need to proceed further. Okay, so suppose consider this example, factor of 1 is written as 1 and here factor of 2 is taken as 2 into 1. So if I substitute here, it is 2 into factor of 1 and factor of 3 is 3 into 2 into 1. So here you can simply substitute with it 3 into factor of 2. So just look at this statement. 5 into factor of 4. So in the functions we have seen. So what is a function? So whenever you want to repeat the same code again and again, you will use the concept of function. So instead of rewriting the code again and again, function is a sub part of a program which executed when it is called. So based on the function call, where the function was defined, that part of the program will be executed. The control immediately go to the function definition and it will execute. Here in this case, so first where function declaration was made, function declaration was written above the main function in fact of int. And inside the main function, function call was made, and after outside the main function again you will write or define the function definition, and inside some contains whatever the logic you want to write, you will write it there. So here look at the statement. By seeing this statement, we can generalize this one. Consider this one, 5, it is n into fact of n minus 1. N into factor of n minus 1. Just I have generalized n with n. N into factor of n minus 1. So what is factor of n minus 1? Here the function call is fact. Function call is fact. And here I have taken factor of n minus 1. This is your function call. So whenever a function calls itself directly or indirectly, that is called recursion. And all the local variables takes their memory from the stack. So what is a stack? So we have the memory fragment, that is like this: initialized data, uninitialized data, stack and heap. So suppose this is your memory fragment, and here whenever we write something like this inside the main function in int a comma b or whatever the declarations we have made, so these variables are local to the block. Okay, those variables will take the memory from the stack part of the program. So from the stack the memory will be allocated. So stack is one type of, it is a memory fragment. So and how a stack will be? This is your stack, and stack always grows in this direction. So means stack follows last in first order. Means the elements that are placed on the top of the stack are the first one to be retrieved. Suppose I am placing like this: 1, 2, 3, 4, 5. Element 5 is the last data value that I have placed on the stack, but it was the first one to be retrieved from the stack. If I want to access this one, I have to remove all the elements on the stack. So this is the sample program for the factorial. So int fact of int n. So how to write a factorial to find the factorial of a given number in using recursion, or write a C program to calculate factorial of a number using recursion. So always we will include the header file, and next the main function, and again int. So this is a recursive function. So what you will do, you have to declare the function call above the main function. So here just take the variable return type. Have we seen in the last session how to declare the function, the syntax of the function declaration: return type, function name, and the parameters. So int, so we will declare whatever the variables we will use there, int n comma, so printf, enter any number, scanf, %ld comma address of n. So here we have used n, so we have declared it. Next one, we will take one variable to assign the function call to a variable, and printf %ld comma k. You can take any variable here. Someone will take result. You can take any variable. Just assign that function call to a variable. So this one get closed, and we have used k also here. So declare that. So this is your main section. So here we have declared the function declaration was done, function call was made. Now function definition. So how to write this one? Int fact of int n. So in this case, how many inputs we are giving? So in the function declaration, in the last session I have discussed, in the function declaration you will pass whatever the inputs we are giving, only those data types will be passed as the parameters in the function declaration. So here how many inputs we have? To calculate the factorial of a number, we have only one input. If I give 5, my result should be 120. If I give 4, 24. If I give 3, 6. Like that, factorial of any number should be printed on your screen. So how many inputs we have? Only one input. So just pass that data type here. Okay. And here the function call. What is the syntax of function call? Function name and list of parameters. So this is your function call, function declaration, and this is your function definition. So now how to call the recursive function. So what is a recursion? When a function calls itself directly or indirectly is called recursion. See, always recursion follows the if-else structure. Recursion always follows, or recursion will be in the form of if-else construct. Like, why it is in if-else construct? Means we need to identify the base condition. We have seen in the last example, if you don't put any base condition, your recursion will go in an infinite stage. Finite recursion. Infinite. So first you will decide the base condition. So what you will decide? If n equal to 1, return 1. When n reaches to 1, means from n starting we will give 5. When n reaches to 1, stop. So return 1, else return. So we have seen that example, fact. How I have written? It is finally it is fact 5 into fact of 4. So if you generalize that one, n into fact of n minus 1. This is the case. N into fact of n minus 1. So we have divided the problem into smaller sub-problems. Return n into fact of n minus 1. That's your program to calculate the factorial of a given number. So let's see this one. So here we have given passed the parameters, only one input was there. Int n comma k, enter any number, 5 as the input. I have entered 5. Next, k is equals to fact of 5. k is equals to factor of 5. In the first case, n value is 5. So, this is your function call. So, whenever the compiler sees these line, the function call, so control automatically come to the definition part. So, it will search where this exact code was defined. So, here it was defined. So, 5, int 5. Now, come here. So, always here in the recursive approach, it will take the memory from the stack. All the data will be loaded in the stack. Stack is one kind of memory. So, this is your stack, okay. Means always an activation record is maintained in the stack. An activation record, whatever the process is doing, we are doing here, that record will be maintained in the stack. So, first, actual execution of your program starts from the main section. So, all the contents in the main section, whatever we have written here in these lines, the data will be first loaded in the stack first. So, we have seen, just now I have explained. So, stack grows in this direction, means here, first in this section, the contents, the main section will be loaded in the stack. So, this section will go and takes place. Next, so whenever the function call is initiated, the control will jump to the function definition. So, now here, if what it is, if n equal to 1, return 1. So, we will see what is the value of n? 5. 5 equal to 1. Condition false. 5 is not equal to 1. Control will jump to the else block. Else return. What are the statements written in else? Else return 5 into fact of n value is 5. 5 minus 1, 4. Fact of 4. Fact of 4 again. So, it is fact of 4. Now, again function call is initiated. So, now again a record will be maintained here. So, if n equal to 1, return 1, else return 5 into fact of 4. So, what is 5 into fact of 4? Again a function call is initiated, fact of 4. So, this is your stack. Next, four into fact of 4 minus 1, 3. So, again fact of 3. Fact of 3 is function call. Previously, it is 5 into fact of 4. So, now n value become from 5 it is 4. So, 4 into fact of 3. Fact of 3. Again a record will be maintained. 3 into fact of 3 minus 1, 2. Next, 2 into fact of 1. So, now what is n value? N is now 1. Previously it is 5. In the last case it is 4. Again it is 3. In the previous case it is 2. Now it is 1. So, now if n equal to 1. 1 equal to 1. Yes, condition true. So, what we have written? Return 1. So, now it will give the result back to the calling function. In the last session, we have seen in functions, so with parameters and with return value. So, what is the keyword of the usage of return, or what is the working of the return keyword? So, whenever a return or command is issued, written in the program, the control will directly take the values back to the calling function. So, same here. Here, fact of 1 is a calling function. So, from there, we have created this one, the record. And now the value 1 will be go back to the calling function again. So, it is 2 into 1, that is 2. Now, this value will move back again. 3 into 2, that is 6. Next, 6 into 4, that is 24. Now, again fact of 4. 5 into 24, that is 120. So this is how a activation record is every time it is maintained, and if you want to retrieve the last value, obviously first we will load the contents of the main section. So all the values on the top of the stack will be removed, and we have written one statement in the main function, that is printf %d comma k. So 120 will be printed on your screen. So this is how a function calling itself, this is recursion. So here we have taken the base condition as 0, that is also okay, you can take it, no problem. So if n reaches to 1, return 1. You should not return 0 because factorial will be 0 then. So return 1. If n equal to 0, return 1. Next, suppose another program. Write a C program to calculate or sum of individual digits of a given number using recursion. See, what is sum of individual digits? Consider this example. Sum of individual digits 1, 2, 3, 4. Suppose if n is equals to 24, sum of individual digits will be 1 plus 2 plus 3 plus 4, that is 10. 3 plus 3, 6, 6 plus 4, 10. You should get the answer as 10. This one we have done in loops also, but using recursion, how can we do? Because when a problem is given in recursion, you have to split that problem into smaller sub-problems. So here n value is 1, 2, 3, 4, and you need to get the sum of individual digits. How to split this one? So suppose, let's take the function name as something. This is your function call, sum of individual digits. So I have taken my function name as sumd of n. See, first you need to identify how many number of inputs are there. In this program, there are only one input because we are giving 1, 2, 3, 4 as the input, and it should display the sum of the individual digits. So only one input. So what is the function call? Whatever in function call, what we will pass? Only the input parameters, list of parameters, whatever the inputs that you will pass in the function call. And in function declaration, how you will write? Int sumd of int n. So this is your function declaration. This is your function call. So now, how you will split it? Suppose sum d is a function call and n value is 1, 2, 3, 4. Okay. So sum of individual digits. So in the previous case, what we have done in the factorial? Factor of 2, if you want to calculate 2 factorial, it is 2 into 1. And you can substitute 2 into, in the place of 1, factor of 1 we have written. So means it is n into factor of n minus 1. We have splitted that complex problem, whatever we have, that n input into smaller sub problems. So here we have this problem. First we need to identify what is the question exactly. Sum of individual digits. First we need to retrieve the individual digit in the program. So the last individual digit is 4 here. So how you will retrieve the last individual digits? By applying the modulus on the given number. Suppose 1, 2, 3, 4, if you divide that one with 10, so by applying the modulus, you will get the remainder. So 4 plus sum d of 123. Let's see this one. So I have retrieved the last individual digit plus sum d of, what are the remaining digits? Remaining digits are 1, 2, 3. So n modulus 10. So by applying which operator I got this one? Obviously it is modulus operator. Plus sum d of. So here it is 123. By applying which operator you can get the quotient? By. So this is your recursive function. Sum d of n by 10. So that's all for this session. In the next session we will see pointers in C. Thank you.